Good morning, everyone. Thank you for joining us for this month's Sustainability Lecture Series. So, before we begin, I would like to ask everyone to join me in a short prayer.
Let me be the change I want to see, to do with strength and wisdom all that needs to be done, and become the hope that I can be. Set me free from my fears and hesitation. Grant me courage and humility. Fill me with spirit to face the challenge and start the change I long to see. Today I start the change I want to see. Even if I'm not the light, I can be the spark in faith, service, and communion. Let us start the change we want to see, the change that begins in me. Today I start the change I want to see.
Even if I'm not the light,
I'm not the light, I can be the spark. Faith, service, and communion. Let us start the change we want to see, the change that begins in me.
Jesus in us.
Jesus in
Now, to give us a brief overview of what the Sustainability Lecture is all about, let's listen to Professor Raymond Tan, Vice President for Research and Innovation at De La Salle University, Manila.
Ladies and gentlemen, good morning, good afternoon, or good evening. It's my pleasure to welcome all of you to this month's edition of the Sustainability Lecture Series. This lecture series is a joint initiative of the International Association of La Salle Universities, or IALU, and De La Salle University. The series was launched in January 2021 to provide a platform to share sustainability-related initiatives done by different resource persons and teams in the different institutions that make up the global IALU network. Nearly 4 years on, this lecture series is still going strong. And the initial team, consisting of Professor Dr. Kathleen Aviso, the current Dean of the Gokongwei College of Engineering, Professor Dr. Alvin Colaba, the Director of the Center for Engineering and Sustainable Development Research, Chancellor Emeritus Dr. Carmelita Quebenco, and myself, has since grown, and part of the team now includes Professor Dr. Aris Ubando of the Gokongwei College of Engineering, our former PhD student and faculty member at the University of the Philippines, Los Baños, Dr. Maria Victoria Nigo Sumagang, and the entire team of the University Sustainability Office of the LSU, led by Executive Director Antonio Nonoy Maralit. This lecture series is envisioned to continue to provide a platform for our joint work, inspired partly by St. Francis's Laudato Si encyclical in 2015, coupled with the United Nations Sustainable Development Goals. Understanding our joint stake in the future and the challenges that face sustainable development, it is incumbent upon the global LaSallian community to share our knowledge and expertise and help drive green growth, not just within the LaSallian community, but for the entire planet as well. Thank you, and I hope you find today's lecture to be very stimulating. Have a good day.
Thank you so much, Professor Tan. So today's webinar is all about developing an integrated framework using multi-criteria decision-making and geographic information systems to evaluate the potential of renewable energy resources in specific areas. Traditional site assessment methods often face challenges such as high costs, time intensity, and difficulty in managing complex geographical data. By using spatial analysis through GIS, it can significantly enhance the accuracy and speed of site suitability assessment. The developed framework, initially applied in the province of Batangas, has a favorable topography and geography for generating electricity from renewable energy resources. Utilizing these resources can help mitigate the impact of electricity supply disruptions in the province, therefore enhancing its energy security and independence. The framework, combined with multi-criteria decision-making methods, such as the weighted aggregated sum product assessment, with GIS analysis using technical criteria and metrics established for each renewable energy type. This framework was used to evaluate the renewable energy potential in selected municipalities and cities in Batangas. Identifying locations with existing renewable energy projects, this was used to validate the framework to ensure its adaptability to other areas. A system that automates the evaluation process based on the integrated framework was also developed for efficiency and accuracy. Ultimately, the presentation that will be shared with us provides valuable insights and practical tools for stakeholders supporting the development of renewable energy and contributing to a more sustainable and secure energy future. I'd like to introduce our speaker for today. Engineer Gilbert Calosa is an assistant professor and program chair at the Industrial Engineering Department of De La Salle PA. He also serves as a faculty member in De La Salle PA graduate programs, teaching in both the MBA and MMP programs. He graduated magna cum laude with a Bachelor of Science in Industrial Engineering from the Polytechnic University of the Philippines in Santo Tomas campus, and earned his Master of Science in Industrial Engineering from Lyceum of the Philippines University in Batangas, where he was recognized with an Academic Excellence Award. Currently, he is pursuing his doctorate in engineering management at the Polytechnic University of the Philippines Open University. He holds multiple certifications, including Professional Industrial Engineer, Certified Industrial Engineer, where he ranked top 6. He is also an Associate ASEAN Engineer, a Certified Specialist in Data Analytics, Certified Kaizen Professional, and a Certified Lean Six Sigma Green Belt. His research projects focus on the application of operations research and data analytics in manufacturing setups, community improvements, and renewable energy systems. Without further ado, join me in welcoming Engineer Gilbert Calosa.
Thank you, Doc Kay. So I'll be presenting my slides. Okay, so good day, everyone. Thanks for having me here at the DLSU IALU Sustainable Lecture Series. What I'll be sharing with you today is our USAID funded project, which focus on sustainable renewable resources. This is in coordination with the USAID ESP Create team headed by Doc Alvin Colaba, together with Doc Andres Mayol and Sir Jeremy Magdaong. So the title of my presentation is an integrated multi-criteria decision-making and GIS framework for evaluating the renewable energy potential. So to give you more context of the study, the USAID Energy or the USAID ESP Create team is initiating projects that focus on the key priority areas outlined in the Strategic Energy Agenda for Calabarzon. These key priority areas are as follows. So we have here the smart grid technologies, demand forecasting, biofuel research, resource site and site assessment, energy system optimization, and energy storage technologies. The team has selected the resource and site assessment because we recognize that renewable energy systems depend largely on the site suitability. So by identifying and matching the potential locations with the appropriate energy systems, this aims to strengthen the province shift toward the renewable energy. So to discuss more, the initial plan of, or the overall plan of this project is to create a two-stage multi-criteria decision-making framework for assessing the sustainable renewable energy resources. The main idea here is to simplify the assessment of renewable energy potential by pre-screening the locations for site suitability. This ensures that before doing actual field surveys or site visits, we can focus our resources, such as time and money, only on the locations that pass or meet the framework's initial screening. But in this discussion, I'll be focusing more on stage one because it is already completed. The stage one involves assessing the locations. Yeah. The stage one involves assessing the locations based on technical criterion only, and then we will embed GIS data to analyze the characteristics of each location. And then once the locations pass the screening, the stage one, we can now proceed to stage two, wherein the locations that pass the stage one will now be assessed based on feasibility in terms of economic, social, and environmental, using the AHP or TAPSIS, another MCDM methods. But in this presentation, again, we'll just focus on stage one because it is already completed and we'll already have the results. So for the introduction of this presentation, in response to the pressing need for sustainable energy solutions, identifying the location and potential of renewable energy sources is a critical step toward their effective utilization and expansion of clean electricity generation. In line with this, creating an MCDM framework for renewable energy assessment with the integration of GIS becomes essential. So there are two concepts here. First is the GIS. First, with its powerful spatial analysis capabilities, GIS enables the systematic evaluation of potential sites by considering multiple technical factors such as resource availability, topography, and infrastructure proximity. Using GIS brings advantages or benefits such as efficiency and time saving, accuracy and precision. It is also cost effective. And lastly, it can also provide visualization and mapping. Here are some of the studies that use GIS in renewable energy planning. Another concept here is the multi-criteria decision making. It is a valuable tool for integrating multiple criteria to weigh citing factors and recommend the optimal renewable energy locations. It provides a structured approach to evaluate conflicting criteria and identify balanced solutions. WASPAS, specifically we're using WASPAS, an MCDM technique that integrates weighted sum model and weighted product model, which are the two prominent MCDM approaches to provide a more robust and reliable decision-making process. So again, these are the studies that use MCDM in renewable energy projects. Okay, so while several studies focus on broader global applications, there's still a need for frameworks tailored to address the unique characteristics of local or regional context. So, based on the research gaps, based on the findings, research gaps include integration gaps, validation limitations, and automation needs. Addressing these limitations is particularly important for regions like Batangas province, which has a favorable topography and abundant solar and wind resources. By the way, we're just focusing on the solar and wind energy because later on the validation of the DOE awarded projects, the data that we have is more on the solar and wind. That's why we selected solar and wind energy. So, the main objective of this study or this project is to develop and validate a framework for identifying, assessing, and recommending potential renewable energy sites. Specifically, we want to identify the potential sites for renewable energy projects such as solar and wind based on technical factors using the MCDM framework integrated with GIS data analysis. Afterwards, we also want to validate the framework's effectiveness through its application to the DOE awarded projects in Batangas province, ensuring its adaptability to diverse regional contexts. And lastly, we want to develop an automated system that streamlines the evaluation process by implementing the validated MCDM framework, which allows for efficient and consistent assessment of renewable energy sites. So what I have here is the flowchart of our methodology. So we can see at the first part, it begins with identifying the potential locations and then establishing the technical criteria and also its weights based on pairwise comparison. And we check its consistency. In this process, we have consulted experts such as renewable energy experts and GIS specialists to check if the criteria and the weights that we have created or established are consistent and aligned with the real world projects. So with that, we will now integrate the GIS and we will have a data for each location under each criterion. The next part of the methodology is the WASPAS approach. The collected GIS data are normalized and calculations are performed for both WSM, weighted sum model, and WPM, the weighted product model, and we aggregate it to create the WASPAS score. The last part of the methodology is the validation, no? Or the validation. To validate the reliability and applicability of the framework, the results that we have from the WASPAS approach are compared with the existing awarded renewable energy projects in the Batangas province. Then, if validated, the framework evolves to a user-friendly system for automated suitability analysis. So this is again the flowchart of our study. Proceeding with the results, so tables 1 and 2 are showing the technical criteria and weights established for both solar energy and wind energy. And also, we have here the required value for each criterion. The next part, we can see here the thematic maps for some key technical criteria we have here or developed using the GIS. So here we can see the GHI for solar energy and mean wind speed for the wind energy. This thematic map shows that the darker the shades, meaning the higher the values or the greater the potential. For example, in GHI, so the darker regions or the darker areas shows that there's a high solar energy potential based on the GHI criterion. And here in figure 3, we can see that the darker colors means there's a favorable and stronger wind conditions. So now let's proceed to the collected data. So here, table 3 and 4 shows the collected GIS data for solar energy, and table 4 shows the wind energy. So we can see here the 34 locations, which are the cities and municipalities in the Batangas province, together with their values under each criteria or criterion. So encircled here are the best values under each criteria. For example, here for criteria 1, 2, and 3, Calaca is the best, uh, or the best municipality, or the best location. And also same with the other criterion. So this for the wind energy, these are the collected GIS data. And now, after the collection of the data that we have under each criteria for each location, the results now are normalized. No? So the raw data were normalized to a 0-1 scale to ensure consistency in applying the WASPAS method for evaluating the renewable energy potential. So we use this formula if the criteria is for beneficial criteria, and this formula naman kapag or for non-beneficial criteria. Afterwards, after normalizing the data, we now proceed with the calculation of WASPAS. This combines again the weighted sum model and weighted product model. So the WASPAS score for each location was computed. The WASPAS score for the required values in each criterion was also computed as the minimum threshold for identifying the suitability of the location. For example, in solar energy, the minimum WASPAS threshold score is 0.7916. And we can see that in the decision column, 21 locations are meeting or exceeding this benchmark, making them suitable. Highlighted here are the top 5 locations demonstrating strong potential for solar energy development based on their WASPAS scores. For wind energy, the minimum threshold score is 0.4879, and we can see that 27 locations are deemed suitable. Highlighted here are the top 5 locations again, showing their exceptional wind conditions suitable for wind energy generation. The next part is, of course, the validation. So here, in the validation, the framework's effectiveness was validated by cross-referencing its results with the DOE awarded renewable energy project locations in Batangas. The data we have is for solar and wind energy projects. So we can see in Table 9 that 13 out of 15 DOE awarded locations were correctly classified as suitable by WASPAS, indicating strong alignment with real-world approvals. We can also see in Table 10, 12 out of 13 DOE awarded wind energy locations were accurately identified, with one misclassified, demonstrating the framework's high validity for wind energy potential. But also to add, we have calculated the precision and recall values for the framework. So Table 11 shows that there is a high recall values for both solar and wind energy, demonstrating their effectiveness in identifying the most suitable locations aligned with the DOE projects. However, we can also see in this table that precision values are moderate, especially for wind energy. This indicates there's an overestimated suitability. It is based. It is due because we only rely on technical factors on the GIS-based technical criteria without considering other non-technical factors such as social, economic, and environmental. So after the validation, the final objective of this project is to develop a system a user-friendly system that streamlines the assessment of locations. Please take a moment to watch this video walkthrough for more details. Okay.
Welcome to WASPAS system for assessing renewable energy potential. This tool is designed to simplify the process of assessing renewable energy potential by enabling users to input relevant data and identify the most suitable locations for renewable energy projects. Start by selecting the type of renewable energy you want to assess. You will see the default criteria and their corresponding weights as defined by the framework. If needed, you can add new criteria or adjust the weights to align with your specific requirements. Next, enter the necessary data for each location directly into the system or upload an Excel file containing the data. Once the data is uploaded, click the Normalize button to standardize the values for use in the WASPAS method. Click the Calculate WASPAS button to perform the analysis and generate results. Click the Decision button to see which locations are most suitable for your selected energy type. Results will include a ranking of all locations along with remarks on their suitability based on technical criteria. Export the final analysis and rankings in PDF format for reporting and documentation purposes.
Okay, so that's the video walkthrough for the WASPAS system, integrating the validated MCDM framework and GIS data.
Welcome to
So to conclude this presentation, our study demonstrated that MCDM framework with GIS data analysis provides a reliable approach. The application of WASPAS enables a thorough assessment and simplifies decision-making. The validations against awarded project locations showed high recall values, but moderate precision values. Again, this is because we only rely on the technical criteria. The next, the automated WASPAS system ensures faster and more accurate site assessments. And lastly, the framework that we have developed offers a replicable and adaptable solution for assessing renewable energy potential for other regions. So that's it. Again, this is the title of our presentation, an integrated multi-criteria decision-making framework and GIS framework for evaluating renewable energy potential. Thank you for listening.
Thank you so much for that presentation, Gilbert. That was very interesting. Now I'd like to invite our audience to type in any questions that you might have for Gilbert. Okay, while we're waiting, I can start off with the questions. So the first one, I've never really worked with GIS, no? So I'm interested to learn, like, where did you get the data that you used for this assessment?
Okay, Doc. Okay, thank you for that question. Actually, we have consulted because personally, I'm not also an expert in renewable energy. So I'm an industrial engineer. So I'm used to apply projects in companies or manufacturing or service companies. But I accept this challenge for this project, and I have consulted GIS specialists and renewable energy experts to help us gather the data. So we have gathered data, for example, some criteria we rely on the Atlas, Global Solar Atlas and Global Wind Atlas. So some criteria are coming from there, some data. The other criteria, such as terrain analysis, are coming from NAMRIA, and some are calculated based on their using the ArcGIS Pro. So some data were converted into a slope map. So to, to answer you briefly, Doc K, it's more on the consulted GIS specialist.
Okay, thank you. But essentially, the information is like trying to identify available databases already. Is that correct?
Yes, Doc. Some criteria are already available publicly, but
Mm.
some data in some criterion are gathered by our consulted experts.
I see. That's good to know. So, in addition to that, of course, the information that we need to collect depends on the different criteria that you use for the solar energy and for the wind energy. So,
Correct, Doc.
because earlier in your table you just indicated C1, C2. Can you elaborate more on the different criteria that you use for these two energy systems?
Okay, Doc. In this presentation, Doc, yeah. I have here, Doc, na criteria 1 is about direct normal irradiance. Can I show it again, Doc?
Yes, yes, please do.
Po. This one, Doc. Yeah, po. So here are the sorry, but I'm sharing this one. This one, Doc. Criteria 1 is the direct normal irradiance for solar. We also have the specific PV power output, global horizontal irradiance, air temperature, average slope of terrain, and distance from the load centers for solar. And for wind, we consider the wind speed, power density, orography, roughness length, and distance from the load centers also.
I see. Okay, thank you. So these are criteria also that are commonly, ano ba, most relevant types of information that you would need for evaluating solar and wind
Yes, Doc.
potential.
According to our experts, these are the criteria that they are using initially to do some renewable energy projects in selecting locations, Doc.
Were you also able to maybe conduct interviews with DOE, for example? Because I saw that in the later part, you validated your results against the awarded projects. Were you able to get insights from DOE on how they evaluate the projects that were submitted to them?
Actually, Doc, that's the missing link of our project. We aim to do that interview, but because of the time constraint, we just check the website of the DOE about their awarded projects in Batangas. But noted, Doc, that's a good insight po.
Yeah, but actually, what I wanted to say this was maybe instead of your work being validated by the grants awarded by DOE. It could be like the other way around. Like you can help DOE actually evaluate the projects that are being submitted to them by using your tool, because at least yours is more transparent and you can clearly see um, what are the technical performance of that particular technology, suitability in the location, and then you also mentioned that later on you will be including other types of criteria like economic and maybe I don't know. Are you also looking at environmental?
Yes, Doc, environmental, economic, and social.
Oh wow, okay, that's very interesting. Yeah. So I have another question. With regards to the suitability, you mentioned that you had a threshold
Yes,
limit
Doc.
for indicating whether a particular site is suitable or not. Where did that limit come from?
We also compute that, Doc, the threshold WASPAS score by considering, Doc, the required values for each criterion. For example, let me check, Doc. For example, in direct normal irradiance, the required value to have or to be it suitable is at least 4 kilowatts per hour per meter squared per day. So we also benchmark those required values. We use those required values to develop the minimum threshold.
I see. Okay, thanks for that. Did you encounter any challenges, for example, in setting up that threshold value in terms of the criteria that you use for your analysis? What were some of the challenges that you experienced?
Actually, the main challenge is to check or find the right normalization, right normalization technique. Because some normalization techniques are more complex than what we use. So we just check or we just use the most basic normalization data.
Okay, thank you. I can really go on and on. So I'd like to ask first our audience, maybe there are some questions on your end. We'll appreciate knowing what information you'd want to learn more about. Yeah, I think this project is really very interesting and very important, no, not just for the area of Batangas. So I think with this framework you mentioned, we can also adopt it for other regions in the Philippines. Is that correct?
Yes, Doc. That's the main goal, Doc, to develop an adaptable framework.
what would be the like caveats or things for consideration if we try to apply it in a different region, for example?
Um, Doc, it's more on the data of that region. So that's the most time-consuming part of our project is the data collection. So if the region has more cities or more municipalities than what we have in Batangas, so the project would be more time-consuming and also more complex in the analysis.
The resolution of the data at the moment is based on municipality. Is that correct?
Yes, Doc, municipalities and
Okay.
cities in
Is
Batangas.
that the most appropriate or the best resolution that can be used for assessing suitability? Or would you recommend it to be on a smaller scale, like maybe, okay, yeah, maybe you can give us insights on that.
Actually, Doc, that's also our target or how can I say this? Our goal, original goal is to have it in a more specific like barangays or because when we see the projects naman po, we just get the average data for each cities and municipalities, but we're not more specific in which or where in that location in that city or municipality. So, but again, based po on the awarded projects of but DOE, we just see municipalities and cities. That's why we align our analysis with that data po that we have.
I see, I see. So there's still room also to improve on the analysis. Maybe when there's more available data,
Yes,
also
Doc.
no, that we can collect for more information. But how difficult is it? Like how fast is it to perform this assessment? Like if I wanted to use it, for example, in Muntinlupa, what would be my timeline more or less so that I can get an information?
Apo. Actually, Doc, in terms of data collection, maybe it would take 1 to 3 weeks, 1 to 3 weeks. Then once you have those data and validated, running the system is very easy. So it will take only few minutes to have the decision. So again, the data collection is the main concern po.
Okay, thank you. Okay, we have a question from one of the audience. So it's from James. So he said that though he appreciates the comment on how the tool can be utilized by the government to provide locations for site suitability, is the tool can the tool be utilized to provide recommendations for structural consideration?
Uh, uh, to answer po the question, when say the structural considerations, this is not part po of our study. But I think the method that we used, we just tweak the criteria. We just tweak the data that we have. We can use this. No po, we can use the framework or the methodology for structural considerations. But on our study po, we have just limited or we just limit the data on uh, the GIS data. So, yun po, Doc.
Okay, yeah, I think that's a very important note, ano, to know the limitations or the scope of what the tool is really capable of doing. I think it's important to engage the government and other stakeholders. So you can also discuss like what other considerations need to be reflected in the tool so that you also know once you're given this information, you also have that information on the limitations that can I apply this right away or do I need additional information um, before I proceed with the process.
Yes, Doc.
I have a question actually from here on site.
Okay, Doc.
There's somebody here joining us as well. The question is, because you utilized GIS data which you collected, I'm not sure how often does that data change, and if it changes, can it still be updated, or how quickly can it be updated into your model?
Okay, Doc. Actually, Doc, the data that we have gathered is an average data. So I think it changes monthly. So that's why in the framework or in the system that we have developed, we should always update the data that we will input in the system. But the data that we use in the analysis is the average data po of a year. Yearly data po, in-average namin siya. So yun po.
Okay, I see. So maybe, I don't know, maybe later on it is possible to integrate, so that it can be updated automatically when you notice any changes or variations, or if there are changes or variations in the data in your database. Okay, we have a question from Juan. So, do you consider the earthquake and typhoon vulnerability of the sites being considered?
Based on the criteria that we had presented, we did not consider initially this earthquake and typhoon vulnerability criteria, but our the goal of our study or project is to have an initial assessment. Then afterwards, after this initial assessment or after filtering the locations, we can now do the actual field survey or site visits. That's why po, hindi muna namin siya kinonsider, the earthquake and typhoon vulnerability.
Okay, thank you for that. The next question comes from Andrew. So, were the 6 technical criteria the most important ones, or were they constrained because of data availability?
Thank you po for that question. Honestly, these are constrained by data availability and by the time that we have. But based on the experts that we have consulted, these are part of the main technical criteria they are considering when they are doing or assessing locations. There are other criteria that we did not consider because of resource and time availability po.
Okay, thanks for that. There's a follow-up question from Andrew. Given that it's a multi-criteria decision analysis method, typically you would make use of weights to aggregate and get the final score. So how spread out are the weights provided by the experts?
Actually, during our meetings, they are aligned. No, surprisingly they are aligned with the weights that they are considering. So when we are doing the scoring, they agree for the specific values that we assign for each analysis.
Okay, so for this assessment, how did you get the weights? What were the weights that you used for
Actually,
the
Doc,
assessment, and what were the assumptions?
we only use the pairwise comparisons wherein we compare criterion by criterion, and then we use the scale of 1, 3, 5, 7 depending on the importance. So that's why after developing the pairwise comparisons, we check the consistency first before proceeding with the next steps. So actually, it has different iterations because the consistency is not that okay at the first trial. But due to refining the decisions, the suggestions, or the inputs, we have arrived with the consistent pairwise comparisons.
So did you make use of the analytic hierarchy process?
Yes, Doc.
Or okay.
Apo.
And how many experts did you consult to generate the result?
Actually, Doc, to be honest, we have only 3 because we're again limited by the resources that we have. So we have 3 experts po, Doc.
Okay, thank you for that. Is the tool that you developed available for public use, or can anyone access the tool?
Actually, Doc, once you have the link, you can already use po. It can be publicly used, the system that we have. It's a very
Okay,
simple
so
system lang po.
okay, so the users can also upload the information that they have in their respective municipalities, for example.
Yes, Doc. They can also add criterion and weights. They can also modify the weights and the criteria based on their studies or based on their analysis.
Okay, there's a follow-up question from Andrew.
Yes,
Can the weights be obtained from data on DOA projects using, for example, support vector machine methods, or maybe other kinds of techniques?
that's a good input po, Doc. Sir Andrew, thank you po for that input. Maybe we can consider din po ito for the improvement. So
Yeah,
yun po daw.
seems like Andrew is really into this, So why were time? Oh, this is additional. Why were time constraints the issue? Is it due to the funding deadlines?
To be honest, Doc, yes po. Because during our meetings, uh, we have given a timeline and also to be presented also in a conference. So that's why we tried to finish or to complete at least the stage one for us to have a project to be presented in a conference. That's why we have these limitations and also the budget.
Yeah, but I believe this can be like an ongoing process, no? So I hope it can be supported, if not by the funding agency, maybe through other means, maybe through Dela Salipa.
Hopefully, Doc.
And yeah, so this platform is really meant to find people with common goals or common interests. I believe Andrew is also very much interested in energy projects. So maybe through this you can also get connected with each other so you can discuss further on potential collaborative research in the future. Okay, so are there any other questions from the audience? Okay, so maybe I'd like to ask you, Gilbert. So what are, how do you see this project moving forward? Like, what other things do you envision to pursue? Um, yeah, to continue on with this project.
Okay, Doc. Thank you po. First, we are envisioning that this project would proceed to stage two, wherein the predetermined locations are now will be considered or will be assessed based on different factors because we all know naman that technical criteria are not enough to justify that the locations are feasible or possible for renewable energy projects. So we are aiming that this would project would continue assessing the economic and then social and environmental concern also. And also, um, we are looking forward that we can do actual site visits and field surveys because that the main idea po talaga ng project namin is to after the screening have that actual or physical visits. So that's our vision po for this project, Doc.
Thank you so much, Gilbert. Are you open to collaborations? Maybe we can make a call out to those participating in this session, and maybe even those who will watch this video over our YouTube channel.
Sure, Doc. We're very open po for the any collaborations that you could offer.
Okay, thank you so much, Gilbert. I
Thank you,
think we
Doc.
do not have any further questions from our audience. Anyway, you know how to reach me. If you need to reach Gilbert, I can get you in touch with him.
Yes,
So
Doc.
before we move on, I'd like to present the certificate of appreciation to our speaker for this morning, Engineer Gilbert Calosa. We present this certificate in grateful acknowledgement of his valuable contribution as our resource speaker in the LaSalle Sustainability Lecture Series with the topic An Integrated Multi-Criteria Decision-Making Model and GIS Framework for Evaluating Renewable Energy Potential, given this 27th day of August 2025, signed by Professor Alvin D. Culaba, Director for the Center for Engineering and Sustainable Development Research, and Professor Raymond Tan, Vice President for Research and Innovation of De La Salle University, Manila. So let me test. Right. So, yeah, may I request Rio there to maybe take a photo or a screenshot together with Engineer Gilbert Fellows. Okay, so thank you so much. Um, so thank you, everyone. We'd like to hear from our audience to help us improve further how we deliver our lectures and maybe identify some topics that we can touch upon in our future lectures. Leodel, can you please share on the screen our feedback form? Okay, so for everyone, kindly submit your feedback by scanning the QR code or going to the link indicated in this slide. Okay, so with that, thank you again, Gilbert, for taking the invitation
Thank
to
you, Doc.
be our resource speaker this morning. To everyone, thank you for joining us. Please stay tuned for the announcement for our sustainable lecture in September. See
Thank
you
you, Doc. Thank
guys.
you, everyone.